Welcome to the new series of notes for General Organic and Biochemistry class. So to start off with, we're going to talk about the scientific method. To start with, we want to begin by observing our world and asking questions. So what questions and observations do you have? They could be such a thing as, how do I get to a certain location in order to get the right parking spot? You might then form a hypothesis. If I get there by 7 o'clock in the morning, I bet you I'll find a parking spot. You have to then make sure that your experiment relates to that hypothesis. So you need to start testing. If you get there at 7 a.m., does your parking spot open up? Make sure you're not doing things that might be other types of hypothesis or other types of experiments or for other hypotheses, such as if you get there at 9, is there a spot? You have to repeat the experiment for that hypothesis for it to be relating to that hypothesis. That makes sense. You wouldn't ask somebody how they feel about getting a parking spot at 7 a.m. with this hypothesis, for example. So you start collecting data on these experiments. So you set up your experiment, you collect and analyze that data. And at the point that you analyze that data, you look back through the data and you draw conclusions. Yes, I found a parking spot at 7 a.m. You may then have other types of conclusions that you come to. So say that your observation is, but I bet you I could get there a little bit later. You might then revise and repeat your experiment over and over. And this is the scientific method. It is okay to sort of change your hypotheses or, look at different types of hypotheses, but make sure that your experiment does relate to that initial hypothesis that you're trying to look at. Okay. So the center of the scientific method is the hypothesis. And so make sure your experiment points towards that. Hypothesis is not disproved. May eventually and rarely be defined as a theory. So when we have a hypothesis that stays around for a while, it can stay around longer. We can call it a theory. And in really rare cases, it can even go into what's known as a law. So Newton's laws are some of that. But that's really rare. Something to note that many people don't realize sometimes is that you can never prove anything in science. So a lot of times we hear this maybe in commercials or this, that, and the other, that is, scientists have proven that happens. Well, guess what? No, they haven't, because that doesn't ever happen. But we can say, like, the data leads us to believe that this is what happens. And it may lead us to believe that that's what happens now. And as we get more data, we might find out that, in fact, it leads you to a slightly different conclusion or a different conclusion altogether. That said, we can say facts are facts. Let's move on and get on with it too. Okay. So next we want to talk about how to write things in scientific notation. This is a very important skill. And you all probably realize that writing a number this huge, you just get lost in all the zeros. Same way, writing a number this small, you get lost in all the zeros. So we try to write in scientific notation instead, because that number that I have highlighted in yellow, I can just write this way. So it would be 1.01 times 10 to the 11th. Or that small number that I have written there could simply be 5.4 to the negative 8th. So notice if it's a really tiny number or less than 1, we're going to the negative 8th right here. Oops, sorry, that is in white. Negative 8. That's originally what that said. If it's a very large number, this goes to the positive 11th. Let me show you what I mean here. So what we do is our goal is to have one digit between the numbers 1 and 9, and then a period that's there. So if we have a really large number or one that's greater than 1, we start with a decimal point where it would be. Whether you know it's there or not, it still exists. So wherever that number ends, there is a decimal point right there. Okay. And so what we're going to do if that's a large number is we're going to start moving it to the left. In this case, we go 1, 2, 3, 4, 5, and 6 times we move that to the left. So what that means is that we can take this new decimal and we can abbreviate this number as 3.2. I'm giving you all the whole numbers that are there. And since we moved it to the left 6 times, it becomes times 10 to the 6th. Okay. Now let's go on down. If the number is really small, so less than 1, we're going to move the decimal to the right instead of to the left until you reach that non-zero number. Now, the difference is here, we're going to put this to the negative x. So that's what I was pointing out above. So we go to a negative x. And so let's say we have a number like we have right here. I'm going to take that decimal point, and these tend to be written down a little bit more so you can see them a little bit more, and put it over 1, 2, 3, 4 times until I hit my first whole number or number that's non-zero. So I would write this as 4.65 times 10 to the negative 4. So we certainly need to practice, and I've got a video for that. If you want to start that video, what you can do is pause it and try to do those problems, and then I'll be right there to help you. Thank you much.